Hello everyone and welcome to another brand new stream. And if you're following me, you know that I'm covering YouTube system design interview questions. So um, I want to continue on that very same subject because it's really important, and also there's a lot of things involved um, in YouTube. It's not just someone uploads a video and you watch it, but there are other components to it: searching, recommendation, then how do you notify the subscribers, things like that. So today I want to cover the search, YouTube search. How is it so good when it comes to finding the relevant videos and displaying them to the user? So let's say that ask why YouTube search system design interview questions. So let's see what this will uh, throw back at me. So here I have one. Since they are for freshers, um, it gives you a very small uh, paragraph, which is the answer to that question, and that's fine. Later, you can dive deep into each point, each topic, each component. But for the time being, let's just keep things very simple. So the first question is, how would you design the high-level architecture for uploading a YouTube video? Okay, so what I'll do, I'll just copy this in my MD file and read the solution. Okay, how would you design the high level for uploading videos? So this is not okay. Did I mention? Okay, what was the prompt that I gave? No, five YouTube system design interview question on YouTube search. I think it gave me the general questions that an interviewer can ask you for YouTube system design question. I forgot to add, I want to specifically dive deep into the YouTube search aspect of it. So how would you design search to handle typos, misspelled queries? So it uses fuzzy matching and edit distance algorithm, Levenstein distance. No clue what this is, Levenstein distance. I know have sign distance, which is given 2 points, A and B. You can calculate the uh, shortest distance between those two. Typically, you use such things in punch in and punch out uh, by extracting the latitude and longitude, and then you will have the latitude and longitude of the location where you want it to be punched in. So then you can create a radius, and okay, so I'm not going to go into that. uh, so let's say, how would you design to handle typos and things like that? The first one is use fuzzy matching, and then the second is edit distance algorithm. um, I exactly do not remember how you implement fuzzy matching. um, okay, So at query time or maintain a pre-computed spelling correction dictionary built from common. Okay, you use Elasticsearch, and then you have fuzziness parameter before hitting the inverted index. Okay, this solution contains so many technical words which I'm not aware of. What is inverted index? I know what an index is, so it's a DB object which will a kind of like a pointer. But what is inverted index? Okay, so I'll just summarize the answer of the first question. Whatever I understand, use uh, fuzzy matching. Then it's edit distance algorithm. Edit distance algorithm, and then you have a pre-computed dictionary, pre-computed spelling correction dictionary. Okay, pre-computed spelling correction dictionary. So it is pre-computed, so the question is when and where is it stored? And then I can say use things like Elasticsearch engine, support this natively via fuzziness parameter. Okay, use search engines like Elasticsearch with some fuzziness parameters. And we expand before hitting the inverted index. How do you scale search to handle millions of queries per second? Shard the inverted index across multiple nodes. Okay, so before going further, let me open another as a chat GPT. What is fuzzy search? Okay, so fuzzy search is a search technique that finds results that are similar to the search query, typically used for typos, missing characters. Suppose the database contain. So this is going to be exact search. Okay, so in exact search you need exactly as it is. I mean, I got the point, but how does this algorithm work? Most fuzzy search algorithm measures how close two strings are. Okay, Levenstein distance. Insert a character, delete a character, replace a character. Change, replace O with A. Distance is 2. The smaller the distance, the more similar the words are. Did you mean Python tutorial? Okay, where fuzzy search is used. Some database support fuzzy search directly through extension. Okay, so there's pgtrgm select star. I thought this is called wild card pattern characters and not even if it's is stored as John. Seriously, I was not aware of this feature in Postgres. Query name value fuzziness auto. Okay, so this is 30-second answer. It's a search technique that returns results that are similar to user query rather than requiring an exact match. Okay, it commonly used to handle spelling mistake, typos, and minor variation. Use string similarity. Is it KPG algorithm? Uh, Something like that. It's widely used in search engine, e-commerce website, application, where search. Okay, so to summarize this 30-second answer, I'll say, what is fuzzy search? Used for searching the entered query which might have typos, spelling mistakes, or missing characters, used in search engines, e-commerce websites, etc. And it uses the what's the name of the algorithm? Levenstein distance algorithm. Okay, what are inverted index? What are inverted index? So these are all concepts commonly searched in search system. Fuzzy matching is a process of finding records that are approximately equal. Okay, I got this point. This is the most common algorithm is the Levenstein distance. So you either insert, delete or replace and then calculate the distance. The less the distance, the closer are the character. This is one of the most common interview questions. Instead of computing correction for every query, many search build a dictionary of valid words beforehand. Okay, so there's already a dictionary of valid words. The search engine stores this. Doesn't compute against millions, instead compares only against dictionary words. Usually not inside the application, it lives inside the search engine. Every index field maintains a term dictionary. An internally elastic store unique terms. This acts as the dictionary for autocomplete or stored in memory. So they rely on the tree data structure or BK tree, which I've heard of black and red trees, uh, but uh, what is BK tree? No idea. Elasticsearch support fuzzy search directly. Okay, so you have a get request with a URL products underscore search. So I think it's inbuilt in Elasticsearch fuzziness auto. It means choose edit distance based on word length. This is how many search engine process a query. Okay, so suppose the user enter. Instead of immediately searching the index, the search engine first expands or rewrite the query. Spelling correction, possible expansion. Now search the index. This process is called query expansion or query rewriting. Better recall, find more relevant document, typo correction, synonym support. What is inverted index? Okay. An inverted index is a code data structure used by search engine to make text search extremely fast. So instead of storing document and the word, store words, hence the term inverted. Suppose you have three documents. Doc 1, I love pizza, I love burger. So normal storage would look something like this. With an inverted index, the engine store I is present, doc 1 and doc 2. Okay, why is it so fast? Without an inverted, read doc 1, read doc 2, read doc 3, and so on to find the word in which, to find the doc in which the search query is present. So the lookup is much faster putting it all together. So we have the user search query. It contains a typo. First compute the Levenstein distance and then query expansion, followed by a search in the inverted index. Rank result, okay, based on vector scoring and return top results. Hmm. So to summarize everything that I just covered, um, we have the user query, okay, uh, with typo, and then it is fed to a elastic search engine. um Wait, uh what is the second step? Okay, so pre-computed dictionary. Hmm, so compute the Levenstein distance and then have a dictionary of valid words, and then you have the fuzzy search and the inverted index, and you perform vectorization, and then you have finally the result. Okay, so the second question is, how do you scale search to handle millions of queries per second globally? Every time I encounter such question, I just like answer, increase RAM, CPU memory, servers, things like that. But you you can solve every system design problem with that approach. So uh, not an acceptable answer. Okay, shard the inverted index across multiple nodes. So no single machine holds the entire index. I mean, that's fine, but how do you create inverted index for videos? I think, let me ask this, how do you create inverted indexes for video. Okay, so this is an excellent system design question because videos are not plain text. The key idea is you don't index the video, you index the metadata that and text extracted from the video. Okay, got it. So I can probably, how do you create inverted index for videos? So the answer is you create inverted index for the video metadata and its transcript if you have it. But these days, uh, I assume every you can generate the transcript of every video in any language that you want. So while you're uploading, you can also extract the transcript and then create an inverted index for that video. Okay, you shard the inverted index. The next one is replicate each shard across region. Okay, put a cache layer in front of very common or trending queries, load balancers, search requests across replicas. Okay, first what you do, you shard the inverted index, you replicate the shards in different region, and from there you place CDN or Redis cache, and finally you have a load balancer. Wow, so many things. Now how would you design search filters? Uploaded date, duration, channel, or view counts? Oh, okay, so if you have videos uploaded, I think currently YouTube search doesn't support filters, but if you want to design, filters for search, then how would you do it? Store these as structured fields alongside the indexed text, title, description in the search document itself. When a filter is applied, the search engine narrows the candidate using where clause, things like that. What happens on the back end when a user submits a search query end to end? Okay, so we have a API gateway, there might be some service, then you parse the query and tokenize, apply any filter if present, and then search in the inverted lookups across shards, candidate video ID, then rank them, and you fetch the details, often with pagination. How do you keep the search index up to date when videos are added, edited, or deleted? So I think they're done in the background. Uh, they're stored in a message queue, something like Kafka, to the indexing pipeline. So uploads and blocked and delete are flagged, and the index is eventually consistent with the source of truth with the DBs. Okay, so let me copy this. Fourth, and then you have, this is the fifth question. and this is the third. So how would you design search filters? uh,